Okay, continuing in OLI Mod 7, we're going to move back to our serial data, take a look at a dot plot for the calories variable, and then discuss some specific characteristics. So the first is shape. We just talked about those four different shapes: skewed left and right, bell-shaped, and uniform. So we'll see if that data fits one of those. Center, I mentioned a little bit before, kind of thinking about that typical value, but let's take a look actually in YouTube. I'm going to bring up this TED lesson here on balancing, and it's going to apply to our dot plots because for center, what we're really looking for is the place where we can get that dot plot to balance. So let's take a look at what's here.
A famous ancient Greek once said, "Give me a place to stand and I shall move the earth." But this wasn't some wizard claiming to perform impossible feats. It was the mathematician Archimedes describing the fundamental principle behind the lever. The idea of a person moving such a huge mass on their own might sound like magic, but chances are you've seen it in your everyday life. One of the best examples is something you might recognize from a childhood playground: a teeter-totter, or seesaw. Let's say you and a friend decide to hop on. If you both weigh about the same, you can totter back and forth pretty easily. But what happens if your friend weighs more? Suddenly, you're stuck up in the air. Fortunately, you probably know what to do. Just move back on the seesaw, and down you go. This may seem simple and intuitive, but what you're actually doing is using a lever to lift a weight that would otherwise be too heavy. This lever is one type of what we call simple machines, basic devices that reduce the amount of energy required for a task by cleverly applying the basic laws of physics. Let's take a look at how it works. Every lever consists of three main components: the effort arm, the resistance arm, and the fulcrum. In this case, your weight is the effort force, while your friend's weight provides the resistance force. What Archimedes learned was that there is an important relationship between the magnitudes of these forces and their distances from the fulcrum. The lever is balanced when the product of the effort force and the length of the effort arm equals the product of the resistance force and the length of the resistance arm.
Okay, I'm going to stop the video there because that really is the important part for us. So our measure of center is where this fulcrum needs to be in order to get the two sides to balance. So I really want to just think about sort of having that fulcrum start in the center of our range, and then we'll move it to one side or the other depending on where we have the larger amount of data, and that's how we will find center. For spread, we've already talked about really two important things about spread. We want to be able to name the total range of that data, but we also want to talk about maybe where most of the data is, or where that typical data values might be. And then outliers, for right now, outliers are just going to be anything that lie outside of the pattern and the general variation among most of the data. So let's go ahead back to the cereal brands data. We're going to make a dot plot again. So graph, then dot plot, and this time I want to use the calories column, and I don't need to worry about anything else. I'm just going to click compute. So there is the distribution of our calorie data. Why don't you pause the video, see if you can come up with each of these characteristics, and then come back and see if we agree. Okay, you can see what I put there. The shape is bell-shaped. It's not a perfectly symmetric bell, but certainly we have one central peak and then tapering off on each side. I think the center is at 110 calories. The spread, my explanation again talks about the total range and then where we find most of the data. So I've said calories range from 50 to 160, though most cereals have calories from 90 to 120. And for outliers, 3 cereals have a very low 50 calories. I think those are really the only outliers I would identify here. 160 is certainly very high as well, although it's kind of continuing in the pattern of the data and tapering off there, so I wasn't going to list it here. Something like that, if you thought that maybe this 160 calories was an outlier from this dot plot as well. I'm not going to fault you for that.